Now that we have defined the various properties in a circle, most importantly the chord and the diameter, now comes how we connect the diameter with the basic definition of circle. I'm talking about the radius of the circle. So how do we connect the radius with the diameter? Is the biggest question in the session. So let's see this session about connecting the diameter with the radius of the circle. So let's see how the radius and diameter are connected for the circle. So in order for understanding these two combined together, let's take the circle into consideration. So here is a circle. Now for this circle, clearly I know that the radius is the line joining the fixed center to any point on the circle. So here I have this distance to be the radius. C is the center. Say my P is out here. So clearly I know that the line joining the fixed point to any point on the circle, that is CP, is the radius. And then let me extend this line to cut the circle on the other side. So here this line extends to cut the circle on the other side, say at Q. So this point is Q and this point is P. Now here I clearly understand that now CP is the radius and CQ also is the radius, because the other side of the circle, if I see, the line joining the center to any point in the circle is also the radius. So CP and CQ are the radii for the given circle. This part being the radius and this part being the radius. This also is the radius. Now, diameter. How did we define diameter in the previous session? A diameter is a chord which passes through center of circle. Now clearly when I see the line PQ, this seems to be a chord which passes through the center. Therefore, these two radius combine to form the diameter. Therefore, if I see the combined, PQ is the chord passing through center. Therefore, PQ is the diameter according to definition of the diameter. So the whole of PQ forms a diameter, as can be seen here. Also, it is very important to note that my PQ, which is taken out here, PQ is nothing but PC plus CQ. Because when this and this is joined, I get the bigger line. So PC plus CQ is PQ. So let me denote this radius with small r, and then my CQ and CP are equal. Therefore, this being r implies this also will be r. So my CQ also is r. And let me denote my diameter with d. So d is my diameter, r is my radius, which are equal, these two being of equal length. Therefore, each of them is r. So my PQ, which is d, is substituted for d in place of PQ. And then my PC or CP is clearly the radius, which is r. And again, my CQ, which is radius r, is substituted for CQ again for r, which on further simplification gives me d equals r plus r, which is 2r. So I find that there's a relation which connects the radius with the diameter, that is d equals 2r. That implies, how do you understand the statement d equals to 2r? D being the diameter and r being the radius connected with d equal to 2r implies the diameter of the circle is equal to twice the radius of the circle. So here I understand that diameter of the circle is twice the radius of the circle. Is how we understand the diameter connected with radius. Diameter is always 2r, that is, diameter of the circle is twice the radius of the circle. Two radius combine to form a diameter. Radius plus radius equal to diameter. D equals 2r. Diameter versus radius. Now that we have connected diameter with the radius, with diameter being equal to twice the radius of the circle, now comes the concept on understanding the arc of the circle. Today's session is about arc of a circle. So let's see the definition of arc of a circle. So let's consider a circle to understand its arc. So here is the circle with center out here. So what is an arc? As we see that the rim of the circle is this, so any part or piece of that rim which we find in the circle is called an arc. So as an arc is defined for a circle to be a part or piece of a circle, is how we understand arc. So for this circle, my arc is defined as the part or piece of a circle is called an arc. Is how we define an arc. So how do we define the part or piece of a circle? So imagine I take this part of the circle. So this part of the circle, let me darken up out here. So I have here a part of the circle which is arc. So if I take any 2 points in the circle, then that curved part of the circle between the endpoints is called an arc. Mathematically, an arc is defined to be the part or piece of a circle is defined as an arc. So there can be any 2 points taken on the circumference of the circle and we get any number of arcs. So arc connected with the circle. So in this case, AB is the arc. Note that for an arc, I use the symbol curve because a line segment AB is denoted by AB, which is called the line segment. and a curve deriving from A and B for the circle is denoted by AB, which is called an arc. So the symbol what I put on the top defines for this to be an arc and this to be a line segment. An arc always has a symbol this on its top. So AB is the arc for the circle as given here. The part or piece of a circle is called an arc. Is how we understand the arc. An example in real life is a pizza. When you take a pizza and cut the slice, we get the pizza with its space, and the outer part of the pizza defines an arc. A piece of pizza connected with an arc. So outer face with endpoints taken as P and Q defines an arc. So PQ is an arc with its symbol. That's how we understand arc of a circle. A part or piece of a circle is an arc.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.